This first section of Homework 9, we are going to talk about percents, fractions, and decimals. You may notice that the word percent actually means per hundredth. So we're talking about per hundredths, pieces out of 100. First thing we want to talk about is converting percents, fractions, and decimals to one another. First we'll hopefully review decimals and fractions. You're aware the parts of a decimal are named by fractions. So for example, if I have the decimal 0.245, this is the tenths place, the hundredths place, the thousandths place. So that tells me how to rewrite it as a fraction. This is in the last digit is in the thousandths place. So I'm saying that that is over 1,000. So 0.245 is 245 thousandths. And then if I want to reduce the fraction, what number goes into 245 and also into 1,000? Five goes into 245 49 times, and 5 goes into 1,000. Let's see, 5 goes into 10. 200 times. So we can reduce the fraction and get 0.245 is the same as 49 over 200. And whatever the place value is, the last digit, you use that. So if you had, for example, tenths, 0.6, you would just make that 6/10 and then reduce. If you had it the other way, you had the fraction, 9 over 16, you do long division. So 16 goes into 9 how many times? And remember there's an invisible decimal at the end of every whole number, integer. So I can add zeros. 16 goes into 95 times. 5 times 16 is 80. So then I need to add another 0. 16 goes into 100 6 times. 6 times 16 is 96. And I get 4. I need to add another 0. 16 goes into there twice. And I need to add yet another 0. And 16 goes into 85 times exactly. Okay, of course, I could have done this using a calculator. I could have done 9 divided by 16 and gotten 0.5625. So that would have worked as well, putting it in your calculator to get this value. Okay, now what if we want to convert decimals and percents back and forth to each other? Remember, percents are out of 100. In a decimal, the hundredths place is 2 decimal places to the right. So to convert percents and decimals, we're simply going to move the decimal places. So if I have 0.32 and I want to change that to a decimal, it is a decimal, if I want to change it to a percent, I just need to move my decimal 2 places to the right, giving me 32%. If I had, for example, 0.053 and I want to change that to a percent, I've got to move the decimal 2 places to the right, and I'll have 5.3%. Notice if the decimal's at the very end, I didn't have to actually write the decimal point. In this case, it's not at the very end, so I do have to write it. What about the number 1.2? Well, when I move its decimal 2 to the right, there's an empty space, so I have to fill that empty space in with a 0. So that's going to give me 120%. Okay. Now what if I want to go the other way? Let's suppose I have 16%. I have an invisible decimal. It's here at the end. I just need to go backwards to turn it back into a decimal. So it becomes 0.16. If I have 20%, same thing. There's an invisible decimal here at the end. So I need to move it back to the left 2 places. So that's 0.20. But as you know, with decimals, we don't have to leave the zeros on the end. So that would be the same thing as 0.2. And let's do one more. Say 4%. Because if I'm going to move the decimal back, invisible decimal here at the end, back 2 places, I've got an empty space that I have to fill in with a 0. So this is going to be actually equal to 0.04. Okay, let's look at the last way, which is converting percents back and forth to fractions. Percents back and forth to fractions. Okay, if we're going to think of them as out of 100, then we're just going to put the percent over 100 and simplify. So if I have 20%, that's simply 20 over 100. You can reduce the fraction. 20 goes into 20 one time, and 20 goes into 100 5 times. You may have a calculator that reduces fractions for you. In that case, you could actually put the 20 divided by 100 into your calculator and convert that to a fraction. I have 8%. That would be 8 out of 100. They have a common factor of 4. So 8 divided by 4 is 2, and 100 divided by 4 is 25. So I have the reduced fraction. Suppose we have more than let's see, I can use 2.4. 2.4%. Suppose I have a decimal in my percent, and that would be 2.4 over 100. Whenever we have decimals or fractions within a fraction, that's called a complex fraction, and we don't like that. So because there's one decimal place here, I'm going to multiply by a special form of 1, 10 over 10, to get rid of the decimal in there. So I have 24 over 1,000, and now I'm going to reduce that. 24 over 1,000, it looks like 8 will go into both of those. 8 goes into 24 3 times. 8 goes into 1,000. 1,000 divided by 8. 125 times. So we have reduced that fraction to 3/125. Okay, now what if we want to go the other way? We have the fraction. We know that the fraction, a percent, is out of 100, and this particular fraction is out of a 5. So we'd like it to be out of 100. Sometimes we can easily see what they would be. You can say, what am I going to have to multiply that 5 by in order to get 100? If I multiply it by 20, then I'll get 100. So it's like getting common denominators in a way. Just multiply both pieces by 20, and I have 60 over 100, which is the same as 60%. If they work out evenly, that's nice. But what if one doesn't work out evenly? What if I have 5/8, for example? Move it down to the next page. Suppose I have 5/8. So I can say I don't know what goes up here. So I'm going to put a variable, x. And this is the kind of proportion we can cross multiply. Students seem to love cross multiplying. Guess because it's easy. So I end up with 8x equals 5 times 100, which is 500. And then I'll divide both sides by 8. What's 500 divided by 8? 500 divided by 8 is 62.5. So my answer here, 62.5%. Okay. Let's maybe do one more. Let's do 13/15. So that's out of 100. So I'm going to cross multiply. When I do my cross multiplying, I'm going to get 15x equals 1300. Or I should say 1300. I'm going to divide both sides by 15. And what am I going to get? 1300 divided by 15. Oh, look at that. This is a repeating decimal. Really, it goes 6 forever, but whenever I stop and round, it becomes a 7. So then you have to know which place you want to round to. So let's suppose I'd like to round to the 10th place. So I'm going to look at the 10th place number, which is this first 6. You look to the number to the right. If it's 5 or higher, you add 1 to that one. So that's going to be approximately 86.7%. If they had told me to go to the nearest whole number or to the nearest percent, I would have said 87%. They've gone to the nearest 1 decimal place or 10th place, it would have been 86.7. They'd said to the nearest 2 decimal places or 2 hundredths, I'd have said 86.67. Okay, so you can use percents to figure out how much you have of something. So let's do an example like this. Marion wants to go on a trip with her club that costs $380. So far, she has saved $250. What percent has she saved? You could also ask the question, what percent does she need? So let's make it like a part A and a part B. What percent does she still need? Okay, she has $250 out of $380. So that's the fraction that she has. Remember, when we have a fraction, we are going to have to change it to a percent or a decimal. Let's just change this first to a decimal. 250 divided by 380 is 0.65789. Approximate 0.6. What was it? 65789. Remember, we're going to change it to a decimal. To a percent. It is a decimal now. We want to change it to a percent. So that's going to become what? 65.789%. If you wanted to round to the nearest percent, here's the ones place. Look to the number to the right. It's bigger than 5. So she has approximately 66%. The total amount would be 100%. So she has approximately 66%. She needs, well, what's 100 minus 66? 100 is everything, so that would be the whole thing. So she needs 34%. Say approximately 34%. Okay, so be careful when you read a question like that, or when you're thinking about a question like that you're asking what you think you are, and that you're answering what you really asked. So what she has is 250 over 380, and convert that to a percent. If it had just asked part B, I could have subtracted first and then found out what she still needs. But this way works. The next section, you will solve percent problems in general, and you will look at percent markup, markdown, changes in percent.